All right, let's talk about something that really separates good developers from great ones. We're going beyond just writing Apex that works on your computer. We're diving into how to write professional, secure code that respects user permissions and, most importantly, doesn't break the second a real user touches it. This is a huge step in becoming a top-tier Salesforce developer. So, here's how we're going to tackle this. First, we'll uncover a really common hidden problem. Then, we'll define what's actually causing it, something called field-level security. After that, we'll get hands-on with the Apex toolkit Salesforce gives us, with real code examples. We'll even check out a handy shortcut before we wrap up with why this stuff is so critical for your work. Okay, let's kick things off with a scenario that I'm sure is familiar to a lot of us. It's that sinking feeling, That moment of dread when the code you built so carefully just fails. And it fails out in the wild. I mean, picture this. You just deployed a brand new feature. It passed all your tests, worked flawlessly for your admin user, a real work of art. But then, not even an hour later, the first support ticket rolls in. A user tried to use it, and the whole thing just crashed and burned. So what on earth went wrong? And 9 times out of 10, this is the culprit right here, this dreaded error message. Now, this isn't a bug in your logic. Not really. It's a collision with the Salesforce security model. Your code, in its blissful ignorance, tried to touch a field that the user simply doesn't have permission to see or edit. You've just smashed headfirst into field-level security. So what is this thing, this gatekeeper our code just ran into? Let's get a clear definition. Field-level security, or FLS for short, is a fundamental pillar of the Salesforce platform. It's the ultimate rulebook for your data. It dictates exactly who can see a field, who can edit it, all the way down to the individual field on a profile. And this isn't a suggestion, it's the law. When our Apex code tries to break that law, the platform steps in and throws this exception to protect the data. But here's the fantastic news. We don't have to code blind and just hope for the best. Salesforce gives us an amazing built-in toolkit so our Apex can actually ask for permission before it tries to do anything. The best way to think about this is a really simple analogy. Checking for FLS is just like checking your keychain for the right key before you try to open a locked door. Reading a field, that's one door. Updating a field, that's another door. And each one needs its own specific key. And the process is always a simple 2-step. First, we grab what's called describe information for a field. You can think of this as just looking at the lock on the door to see what kind of key it needs. And second, we use a specific method to ask the system the direct question, hey, does the person running this code right now have the right key for this lock? This table shows you our 3 main keys. The isAccessible method, that's your key for reading data, think SOQL queries. IsCreatable is the key you need when you're setting a value for a brand new record, and isUpdatable is the one you need to check before you change a field on a record that already exists. All right, enough theory. Theory is great, but let's see what this actually looks like in practice. Let's look at some real code that's secure, robust, and doesn't kick off the security model. Okay, here is a line of code I'm willing to bet you've written hundreds of times. I know I have. And this is an unsafe query. It makes a huge, dangerous assumption that every single user who runs this code is allowed to see the description field. So before we even think about building our query, we drop in this simple check. This is our code, turning to the Salesforce platform and politely asking, hey, for the current user, is the account description field accessible? Do they have the read key? And here is the beautiful result. We build the query dynamically. We start our query string with fields we know are safe, like the record ID. Then, and only if that isAccessible check comes back as true, do we tack on the description field. No permission, no problem. The field never even makes it into the query. And more importantly, no crash. And it's the exact same story when we're writing data, not just reading it. This code here just assumes that the user has permission to edit the rating field. If they have read-only access or no access at all, that update statement is going to fail hard. So, you guessed it, the solution is to ask for permission first. We just wrap our logic in a simple if statement, but this time we use the isUpdatable method. This is our code checking its keychain for that edit key before it tries to change anything. And here's what that final safe code looks like. We only try to set the rating field if that isUpdatable check passes. And notice something important. The update call is outside the if block. This is a great pattern. It means the record always gets updated with any other changes, but this one sensitive field is only touched if the user has the right permissions. Now you might be thinking, wow, that's a lot of if statements if I have a ton of fields. And you're not wrong. So for some situations, Salesforce gives us a really handy automated shortcut. So you basically have two tools in your belt, and it's all about picking the right one for the job. The manual schema checks we just went over give you total granular control. They are perfect when you need to build a dynamic query or maybe show a custom error message. On the other hand, you have this method called security.strip_inaccessible. Think of it as a bulk cleaning tool. You just hand it a list of records and it automatically scrubs out any field values that the current user isn't allowed to touch. It's super fast and simple, but not as flexible. Okay, so we've gone through all these checks, these methods, this code. Let's just take a step back for a second and ask the big question. Why does any of this really matter? Why is mastering this so important for you? Look, here's the bottom line. Writing FLS-aware code isn't just about fixing bugs. It's about writing professional-grade software. It stops those awful, frustrating errors. It guarantees your code works for every single user, not just for you with your system admin profile. It ensures that you respect the data security policies that your admin worked hard to put in place. And hey, if you ever dream of building a managed package for the App Exchange, this stuff isn't just a good idea, it is absolutely mandatory. And that's really the question I want to leave you with. It's one thing to write code that works, but the real challenge, the thing that marks you as a true professional, is writing code that is trustworthy, code that's secure, that's reliable, and that plays by the rules for every single user on the platform. That's the standard we should all be aiming for.